So without wasting any more time, I'll welcome Mark, VK3 OHM, who's going to enlighten us on everything to do with laser printers. So welcome, Mark. Thank you for giving up your evening to educate us.
It's not really everything about laser cutters. It's a little bit about laser cutters. It's for those who haven't got one and just want to understand the basics. I'm not going to go into an enormous detail. But we will be using this later and there will be smoke. So if you have to dash outside, I understand. So about a year ago I bought a laser cutter for under $1,000 just to see what they're all about. I thought, well, $1,000, if it turns out to be complete rubbish, it's not a great loss. To be honest, I haven't used it hell of a lot over the last year. I've been distracted by other things. But I've learned enough to know what you need to know if you're considering buying one. And we will do some cutting later of something. Grant's been doing laser cutting for years, and he's brought in quite a number of examples of his work. So at the end of this we can go and have a look at all those examples, and I'm sure he'll explain what they are. So it should be obvious, but a laser cutter's device is a focused beam of light to cut or engrave. Cutting is cutting the whole way through, engraving is just not cutting the whole way through, and that you end up with an engrave. The important things about it is that it's very precise. It's accurate to 0.1 of a millimetre. You can cut most things, wood, plastic, leather. With these hobbyist ones you can cut almost everything, but you can't cut stainless steel. You need a serious laser to do that. And obviously they have to be computer controlled. Now just a bit of safety. There'll be no hazards tonight, but that's the scale they use for eye safety, from 1 to 4, and 4 is the most dangerous, and all laser cutters are class 4. So don't look at them. If you're using one, you should wear eye-safe glasses. What I've done for the purposes of this demonstration is, when it's running, it'll be in a tent, so it'll be quite safe. It's probably safe without the tent, because it has got some guarding around the actual head, but I'm not so sure. So be very, very wary of laser cutters. Now, not all laser cutters are the same. There's 4 fundamentally different types. I only talk about 2 of them. The one you see here, which is called green, is actually blue, but it just means it's in the visible light spectrum. It can be almost any colour, it's just a question of what colour diodes they use. The other type is the CO2 laser, which is in the infrared. Now, that was my first disappointment when I bought this. I've got a green laser, and when I try to cut perspex, it just goes straight through like it wasn't there. I can cut completely black perspex, and I can cut certain types of perspex which are very, very, well, they're not opaque, but they're very low transmissibility. So you got to pick your perspex. Because of its wavelength, CO2 lasers will just cut perspex like hot butter through a knife through hot butter. Sorry. So it is an issue. If you just want to do ordinary stuff, not perspex, except black perspex, a normal green visible light laser is perfectly fine, and they're a lot cheaper. But CO2 lasers are bigger, more expensive, heavier. Although increasingly these days, they're not too bad. So how a laser cutter works, this diagram really shows how a CO2 laser works. The laser is generated in a tube up the back of the laser, and then it bounces around through mirrors and gets reflected into the head, and that bends it down. The beam is focused. That beam then either melts, burns or vaporises the material, depending on how much power you're using and the material. So you need a program to drive it all, and almost always the designs, unless they're very, very simple, are done in CAD software. So they're just an extremely focused and extremely hot beam of light. There's a CO2 laser, which is best for wood, acrylic, leather, almost anything. There's fibre lasers, which I've not had anything to do with, but they're for cutting metals. I imagine they cost a fair bit. And then there's diode lasers. There's a lot of these diode lasers around. They're very compact, versatile, suitable for small scale work, and they don't cut acrylic unless it's black. So you can cut almost anything: steel, aluminium, copper, with a fibre cutter. Anything that's non-metallic. It says that you can cut glass. Wow, that'll be interesting to see. Not tried that. Things you can't cut, or shouldn't cut, is PVC, because of massive toxic fumes, and certain types of reflective materials, like a mirror. If you try and cut a mirror, you won't get very far. You can cut it from the back. So the reflectivity of what you're cutting is an issue. It's got to absorb the energy coming in to heat up, to vaporise. And if it doesn't absorb it, by either it reflects it or it just goes straight through, because the material's transparent effectively at that frequency. There's basically two types. People are often tempted, and why not, to get a very old second-hand dinosaur cutter that's lying around. They're usually a bit limited. You make a file in DXF and you just download the file to the cutter and off it goes. But it's very difficult to control the intensity. It's very difficult to do engravings and things like that. They work, but they're a bit tedious. Most lasers, or any modern laser, uses direct control. The software converts images or whatever it is to G-code and sends it to the cutter, just like a 3D printer. And you've got incredible control. And some setups are halfway between the two. A mixture of file, but a rich file format where you can do other stuff with the file. So all the modern ones are very good and flexible. What does that asterisk refer to? Oh yes, okay. Yeah, because you want dynamic speed control, and most cutters have a jet of air. If you blow a jet of air onto the cutting point, it increases the burning because of the oxygen, and it also blows away all the crap. So this has got a little air compressor here, and it turns it on and off as required. So you can do certain cuts with the air on and cuts with the air off, depending on what you want to do. one of the things you normally produce is a material test card. You've got a piece of material that you want to cut and you want to know what's the minimum power and speed that I can use to just cut through it, because I don't want to waste power. Or what amount of power and speed do I need to get that nice shade of brown on my engraving? It's probably a bit difficult to see, but this one here is quite black, it's quite deep and quite charred. And these ones here are quite light. So the usual procedure is to have a sample of the material that you're going to use and produce one of these, so that every time you come to cut that material you just go, oh, I want that one, that setting, rather than have to guess. This has software, the software I use, and most of the software just say, well, make me a test card, and away it goes. So what can you make with a laser cutter? All sorts of useless things, really. Christmas decorations, name badges. There's a jigsaw puzzle I made over there. An infinite variety of boxes. It's very good at boxes. Almost anything. It's a bit like 3D printing. There are sites equivalent to Thingiverse, which have got 200,000 3D laser cutter things, some of them useful. The only real difference is you're limited to two-dimensional objects, but as you can see, you can assemble them into three-dimensional objects if you really want to. But it's fundamentally a 2D technology. I'll show this this box here I made. It uses finger joints, and there's no glue in that. They're a nice tight fit. It's that accurate that you don't need any glue. And by the way, I've cut on various laser cutters an Aldi key. Anyone know what an Aldi key is? It's a fake $2 coin for the trolleys. I've got quite a few here. If anybody wants some, limit of 2 per customer. I've got pink ones, red ones, clear ones, white ones. It's easy just to knock out. So you're limited to two-dimensional objects, but as you'll see, it's a lot faster than 3D printing. It can move at 400 to 600 millimetres a second, which, think about it, that's pretty damn fast. Here's a few other things you could make. I like the chopping board idea. Not really very practical, but interesting. Or we could make a clock. Engrave the hands, engrave the scale on the outside. All these things that come off the web, there's all instructions to make these things. So, things to think about if you're thinking of buying a laser cutter. One of the main drivers of price is the size. And the bigger the better, but you do have to have somewhere to put it. This one's 400 by 415, and it's probably adequate for most things. You need to think about the technology. Laser diodes are cheap, but you can't cut perspex. You might want to consider getting a CO2 one. They're getting cheaper all the time. What was once 10,000 is now 4,000 and probably will be 2,000. And there's a piece of software which I use, which it seems that everybody uses, called Lightburn. because we're burning with light. It's not the only software, but it's very, very popular. It's not free, but you can do everything you possibly want. I've used a few free alternatives, but they're a bit frustrating. They're not quite as good. I would recommend you make sure your cutter supports light burn, which all the modern ones do. And power. This is 22 watts. You can get a 40 watt version, a 60 watt version, and I think I saw a 100 watt version in diodes. CO2 lasers are typically, they're all 100. That's just the standard power. And that's way more than enough for anything. If 100 watts is not going to cut it, anything more probably won't either. The laser ones are still working out how much power is really enough. But this is 22. It's enough for me. Now, making these boxes, there's a site called boxes.py, because it's written in Python. And there are hundreds of different types. There's circular boxes, there's box with lids, box with rolling fronts on them. What you can see on there is only 20% of the fundamentally different types of boxes that are available. And within each box, you can have as many rows and columns as you like. And you just type the parameters in and go, there you are, and it makes a box for you. So, very, very, very easy. Or you could draw it by hand. It's a bit laborious though. So, we're actually going to make a box. Here's one I've prepared earlier. I've made a box at boxes.py. In fact, I have the box. We'll make another one. That's one useful thing you can make. Kite winders for QRP antennas. Make quite a few of those. That's a little box that I've set up for the purposes of demonstration. It's small, so it won't take long to cut. No glue. We can pass that around. Don't try and pull it apart, it might come apart. So using boxes.py, you make a DXF or an SVG file. Then you cut the box and you assemble the box. That's a light burn. It's got a very fully featured editor on the left here so that you can make any design that you'd want, just a typical CAD package. I've just imported this design from somewhere I made earlier. You can just see it's a whole lot of cuts. And then on the right hand side, there are things you can do with the laser. Move it around, centre it, position it. And then we can do a cut. All right, we'll do a cut. I've put a piece of plywood in there, 3mm plywood. I'll put this on top. We'll see what happens. Okay. So I just, first of all, I frame it. That just runs the head around the outer boundary of the thing you're cutting, just to make sure you've got the sheet in the right place. And then we'll go. It's cutting. Can you see a blue light?
Yeah, under the unit. Cutting the table as well. Yeah, cutting the table.
Oh, smoke's only just starting. It does need to be sited near a window. Oh, I love the smell of burning timber in the morning.
What's the maximum material thickness?
I think with this one it's 16 mil. What you can do, and the software supports it, is you just cut 3 or 4 times. It's so precise that you can cut a very complicated pattern, and if you just do it again, it'll go exactly over where it went before. So if you need 4 or 5 cuts, oh gee, I've gone very close to the edge of the sheet. Well, yeah, you've got total control. If it's going to be a hard cut, you can obviously you turn the power up, and you also go very slow. Now, I'm not sure what I've got set here. I've got 50% power and a speed of 5. 5 is a bit slow. If I put it at 100% power, twice as quick.
We've got a few questions.
Okay, while that's cutting, that'd be a good idea.
John wants to know what type of timber is used.
Well, it's whatever you want. I use a thing called basswood, which is just a very high quality plywood. It's got 2 A-grade veneers on it. Well, that looks like a B. And absolute rubbish timber in the middle. But you can cut, it doesn't matter what it is, it can be MDF, any timber. But the issue is that every timber cuts differently. So you'll need a material test card for each different type of timber, because MDF probably needs more power stroke speed to get through it. So you can in theory use anything, I mean leather, paper, anything, but they will all require different power and speed to get through it.
All right, next question. The making of plastic gears like you find in radio tuning, not a problem?
No, not a problem, except you're cutting plastic. If you want to make them out of acrylic, that would be probably wise. Yeah, I mean, they've got the same resolution as a 3D printer, but I think you probably get a better result because it's doing a linear cut.
Plus you have the inherent strength of the material.
You've got no layers.
Yes, you've got no lamination going on. So, yeah, you probably make a better gear out of acrylic.
But again, they'd be black.
But they've got to be black gears.
They've got to be black.
Grant's got some, well, they're not gears, they're the index plates over there.
I printed.
Oh, and there's gears. And they're just awesome. Particularly his big index plate, it's madness.
One thing I will say is that the laser cutter can get finer accuracy than 3D printing, at least in smaller gears.
Yeah. Yeah, that's probably better for... Is this still going? Yeah, okay. It's a bit slower than I...
One more question.
Yep.
How do you secure the material to the base plate?
Gravity. Below the cutter, there's just a sheet of aluminium so that you don't burn a hole through the table. But I've got a hex mesh above that so that when the beam goes through, it cools it down, but it also is, there's a lot of friction because it's the sharp edges of an aluminium mesh. When it's finished, I'll show you. So you don't need any fixing at all, it just sits there. And it's quite repeatable. If you do a couple of runs, it won't have moved. Just don't sneeze or bump the table. That might cause a problem.
Mark, I had a question for you. How do you ensure that you get the focal length right so you don't damage the base plate?
I'll show you. There's a gadget for that. There's two alignment things which are helpful. This, if you're going to start printing in the middle, cutting in the middle of the bed, you can use this to line up the material on the head so that you get pinpoint accuracy. So you start in the corner, and that's how you adjust the focus. 3 little steps. If it's between 1 and 3 mils, you use the higher step. 4 to 6 mils, the next step, and if it's greater than 6 mil, the bottom step. So it's very focused, and beyond the focus is nothing. Well, not much. It stopped. Well, let's see what has happened. Now I've just got to move the head out of the way so I can get the board out. As I pick the board up, oh dear, it's got holes in it. So now you've got to work out how to put it together. Some of the boxes, and I've done it, they actually engrave on it, left, right, top, bottom. But with something like this, that's probably a bit unnecessary. So, you need 5 hands to put it together. It's only we're nearly there. And now the hard one, 4 sides at once. I think that was a bit ambitious trying to do all 4 sides. Yes, I might do. Here we go. It's a press fit. Here we go. Voila. Oh, it's not quite in. There's no play in it at all. It's a very tight press fit, which is what you want. Exactly the same as the other one we handed around earlier. All right, well that's my quick overview. Oh, yes. might just remove the safety shroud so you can see it. This is an option, you don't need this. You see it's just a hexagonal mesh. But I'll show you the base plate in a second, but it does have the advantage that lots of friction on the surface. So if you're putting anything on there, it won't move. The actual base plate that comes with it is just a sheet of aluminium. And you can see, even with the protection of this thing, it's still making an impact. Without that, it would eventually burn through. Take a while, but I recommend one of those.
When you get the printer, does it come with the hood or is that optional extra?
That's optional. There's quite a few other things you can do or accessories you can add with these. A lot of people put a camera just here, and you can use with the software to line it up. You can actually see where the timber is and get it spot on. And secondly, they have a lid, eye-safe lid, so you don't have to mess around with these portable tents. But that'll cost you an extra $1,000 to have a camera and a lid. But that's an option. I think the other option you need is about 20 metres of this stuff. Yep. If you're doing a lot, I mean, if I was doing something, an intricate cut, which cut the whole of that sheet, there'd be a lot of smoke. All right, thank you all very much. I suggest you go and have a look at all the clever things that Grant's made with a laser cutter.
Well, thanks, Mark, for appreciate it. I'm sure some members have taken away some learnings from today and perhaps might invest in a similar device themselves. Certainly, Grant's been doing a lot of work as well with the lasers and other routers, etc. In fact, the clubs, we do our own name tags now. Grant does our name tags now. Which is one considerable saving, but also allows us to customise the name badges, etc. So we're looking at different ways and different aspects of the hobby that we can branch out into as well. So that's been rather successful. Certainly hours of fun on a Thursday, working out the programming and coding, etc., to get it all happening. But yeah, it's been nothing but a success. So congratulations to everyone who's made that work. Tea and coffee out the back, help yourselves. There's also surplus books there, help yourselves. Some gems, there's some nice monitor stands if you want to put a couple together. But I think there's a couple of ARRL, old antenna books, etc., that you might find useful that have been surplus to the club's needs. So thank you everyone for coming along this evening, much appreciated. Stay safe and we'll catch you next time. Thank you all.